Hi viewers, welcome to NCK Consulting and Training as part of our Java 8 playlist. In this particular video, we will be discussing on different operations that can be performed using Streams API. And before this video, we have covered in our older videos what is Streams API and what are the different ways that we can follow in creating a stream object. And also we have covered what is an optional class, and we have also covered what is method reference. Now let us deep dive into today's topic. So streams operations, how many operations are there that can be performed on streams? Two types of operations or two categories. What are they? Intermediate and terminal operations. What is an intermediate operation? If a particular operation is performed on a stream and the output of that operation is also a stream, that particular operations are called as intermediate operations. What is a terminal operation then? If a particular operation is performed on a stream and the output of that particular operation can either be a primitive value or an object, but not another stream, that particular operation is called as terminal operation. So what are the different examples for intermediate operations? It would be like map, filter, distinct, etc. And what are the examples for terminal operators? So the examples for terminal operators would be like count, minimum, maximum, collect, for each, reduce, etc. Now, what is the concept called pipeline of operations? So basically, for a particular stream, we can perform a pipeline of operations. What does that mean? It means that it will start with a source and then followed by the intermediate operation and then followed by the terminal operation. A pipeline can have zero or more intermediate operations, but a terminal operation will be there for sure. Pipeline of operations for a particular stream will always end with the terminal operation, and there will be a source for sure. Intermediate operations will be either zero or more than one. It depends on the requirement that we deal with the stream. Now, let us focus on the intermediate operations, which are more frequently being used in our regular day-to-day practice. Let us start with the map method. The map will result or give the output as a stream that consists of the result by applying given function to all the elements of the stream. Okay, so when you perform a map operation on a stream, what it will does is stream will have different elements, a set of elements. The function which you ask to apply a map method on all the elements of the stream, it will apply on it and then it will result into a another stream. Let us see that in an example. So here is the example that we have for map operations. Okay, so this is the programmer class which I have written for demoing this particular program. So if you see here, this is a programmer class which will have the name and the skills that particular programmer is aware of. So I have taken this particular class and I have written a constructor and getters and setters as well. Okay, so now coming back to the map operation class, which is our first operation as part of this video. Now I have created a list of programmers here, and using the list.off method, I'm adding three programmer objects to that particular list. Okay, now I'm trying to perform a map operation. What I'm telling to do here is from the list of programmers that we have here, I'm creating a stream and then creating a map operation, and then I'm trying to get the name of the programmer. So the function which I'm asking the map method to implement on all the elements of the stream is I want name from each and every object of the programmer that was added to your list. This is what I was asking the compiler to execute. So this line of code indicates that from this particular list of objects that has programmers. I'm creating a stream, and using that stream, I'm writing a map operation, and inside the map operation, I'm telling the compiler to get the name of the programmers from each and every individual object. And I'm trying to print the values using the for each method. Let me try executing this. See, I gave the names as programmer 1, programmer 2, and programmer 3. So I got the output. So this is how we can perform the map operation. If you want to perform anything specific to all the elements inside the stream, any particular function or anything, this is the best approach that you can follow. The second operation that we have here is flat map. So flat map is a kind of a map operation only, but the difference here is it will collect a stream of collections into a single stream. Okay. Now let us see that in an example to have a better understanding. So here is an example for flat map, and this is also the same list whatever I declared in the earlier program. The same list was used here, but here what I'm doing is for the stream that was created, I'm using a flat map, and then I'm asking to get the list of skill sets that each programmer has. So for a particular object, the programmer have a skill set. So programmer has multiple skill sets. So this is also again a list. So what I'm telling here is to convert this particular list into a stream and then add everything to this particular stream which we have here. Okay, now I'm trying to print all the stream here in this particular line. Let me try to execute this. Run as Java application. So if you see here, all 9 values we can see here. 1, 2, third one, and then 4, 5, 6, and 7, 8, 9. So here we have 9 skill sets. Each programmer has 3, total of 9. And in the output also, we were able to see the 9 values. So the difference between map and flat map is map operation can be used if you want to perform certain function operation on all the elements inside the stream. For that, you will go for a map, and for flat map, if there are multiple or if there are any list objects which you need to convert internally into stream and then group everything into a single stream, in those use cases, you will be going for a flat map. Hope we are clear so far. Now the next operation we have here is filter. Let us try an example for filter. So filter, as the name indicates, what it does is it will select the elements from a stream, and we will be passing a predicate as an input to that particular filter, and it will verify the condition that we have passed in as a predicate, and then it will filter the elements inside the stream. Let us see an example here. So here I am creating a stream using stream.off method from stream static class, and here I am passing 5 elements inside the stream. Now I am asking the JVM to filter the stream and have the words that start with C. So if you see in the list in the stream that we have on the above, we have only 2 elements that start with C. So I am creating a stream here by filtering the above stream which have the elements that starts with C and then printing these elements here. Now let me try executing this program. So we should be getting 2 values now out of 5 stream elements. So because only 2 elements start with C letter, so we got 2 elements here. Okay. So this is the third example which we can think of about filters. Now let us go for the other one, distinct. So this will remove the duplicates from the stream. Okay, now let us go to distinct. So here we have a very good example which we have used earlier. If you see here in the flat map in our earlier example, when we executed this, we see that some of these skill sets are repeating because some skill sets are common for all the programmers. So using the distinct that we have here, we can what we can do is we can filter the values or remove the duplicates. So this is the one which I have used earlier for the flat map, and on the map that was created on the stream that was created using the flat map, what I'm trying to do is I'm trying to do a distinct method operation. Okay, so first let us go with this. I will try to comment this particular code. So that we can see the output only for one particular thing. Run as Java application. Just a second. I think I commented out sysout as well. I need to comment on this particular line. That's the reason we are not getting the output. Let me save this and then execute it. So if you see this here, we are not getting any duplicate values now. All the duplicates were removed because we used the distinct operation on the particular stream that was formed. Okay, now let us go for the next operation that we have. Let me back out the change. And here we have sorted. The next method is sorted. So this sorted method will return the elements of the stream in a sorting order. So there is an option that we can provide a comparator. If no comparator is specified, it will prefer its own natural sorting order. Let us see that in an example now. I'll use the same example here. I'll comment the distinct part and then I'll try to run the Java application. So if you see here, all the elements in the flat map stream were sorted based on the natural sorting order because we did not provide any customized sorting as an input. Okay, and in the last itself you can see the peak operation also. So this is our last method in our intermediate operations list. This also performs the specified operation on each element, mostly used for debugging. So basically, in our earlier programs, for printing the elements of the stream into a console, we were using for each method. So instead of for each, we can use peak as well. So this is the syntax which we can use for peak, and this is the way we can you print the elements using peak operation. So with this, we completed the major intermediate operations that we frequently use in our day-to-day practice. Hope we are clear so far now. Now let us go to terminal operations. Okay, so we have altogether 9 terminal operations. Let us go one by one. We'll start with the count operation. So this count operation is used to determine the number of elements in a stream. Now let us see that in an example. Okay, now let me close all these things and then let me go to the terminal operations and I'll open the count operation first. Okay, so here I have created a stream using stream.off method, which is a static class and the method is static. And I'm just trying to print the count of the elements inside the stream using count method. Let me try to execute this. And here I have 3 because I added 3 elements to this particular stream. I got 3 as the count. The next operation that we have here is minimum and then maximum. Minimum and maximum are the next operations that we have. Let us see the example for that. Okay, I have created the same kind of stream for this example as well. So what I'm trying to do is, so for minimum and for maximum, I am trying to provide a customized comparator. So here, as the description says, for minimum and maximum, it will allow us to pass a comparator and find the smallest value in the stream and then the largest value in the stream. So I have passed the customized comparator now. So I'm asking the compiler to get the minimum value here and then here the maximum value by comparing the length of the strings for all the three strings that are there as part of the stream. So this is the comparator customized one which I have passed in as an input for the minimum method and also for max method. The same comparator I have used on the same stream so that we can easily distinguish the response. So if you see, the minimum value one is Java and the maximum string that we have here in the stream is Spring. So this is how we can use the minimum method and the max method inside the on stream operations as part of our terminal operations. Now the next example that we have here is collect. This is a very frequent operation that we very well use most often compared to all the other terminal operations. Now let us say take our same old example where we have three programmers with different skill sets. Now here I have two things. So one thing is collect and I'm passing it to the list. And here collect, I'm passing it to a set. So here I'm creating a set and here I'm creating a list. Now for list, what I'm trying to do is I'm getting the name of the programmer. But whereas for set, what I'm trying to do is I'm getting the skill set of each programmer and adding it to a set object. So in our previous one, what we were thinking is like this will get all the skill sets, and since we are not using distinct, we should see 9. But let us see the difference now. Let us try to execute and see the difference. So if you see programmer 1, programmer 2, programmer 3. So in the list of programmers, we got the names. So three names are there, we got the three names. But whereas in the skill set, if you see, the duplicates were removed. Only distinct values were there. You did not even ask the compiler or you did not even perform distinct method. Instead, you have performed a collect method here. But why all the duplicates were removed automatically without not being added to the output? Here we have only one angular and altogether we have only 6 here instead of 9. So how do we get that? The reason is we are adding it to the set. As you know, set will not allow duplicate values. It will allow only individual values. If I change this to list, then the situation will be different. Let me save this. And here also I need to change it to list. Okay, now let me try to execute it. See, you have all 9 again. So adding the collection to the set has removed all your duplicates and you ended up with only individual values. So that is the difference. That's the reason even though we haven't used a distinct in our stream, on top of our stream, we were still able to remove all the duplicates and we got only the individual values. So collect method, we can use it and we can add it to a set object if at all we wanted to achieve the concept of having only individual values without any duplicates. So using distinct is one method and using collecting them everything and adding it to a set object is one method. These are the two ways where we can remove the duplicates in case of streams. So hope we are clear on the collect. Now let us go with other for each. For each is the one which we were seeing it right from starting of these examples. For each and every example, I have used for each method for printing the output to the console. Okay, so I need not have a separate example for that again because we were using almost in every program. Even in this particular program also we have for each. Okay, now reduce. So this particular reduce method will take binary operator as input and reduces the elements of a stream to a single value. Now let me show you an example so that you will understand it very clearly. So here I am passing arrays of characters JAVA 8 STE STRE AMS. So basically, I'm trying to club everything into a single value as Java 8 streams. So for that one, what I'm doing is I'm using the reduce method and I'm asking the compiler to consider this as a, you can ignore this particular one and you can compile I mean, you can club everything into a single string. That is the syntax that I have used here using the reduce method. So this reduce method will help me in reducing all these inputs into a single value, all these elements into a single value. Okay. Now let me try to execute this particular program. So Java 8 streams. So based on your requirement, this can be customized in many ways. But what we need to do is we need to pass in the required parameters. If you see here, we need to provide the identity and then we need to provide the binary operator. This is the method syntax that we can use here. Okay, using this one, we will be able to achieve it very clearly. Hope we are clear so far. Now, let us go with the next example, next operation. Next operation is find first. So returns an optional class object describing the first element of a string. Since we will be covering optional here, that was the reason we covered optional in our earlier videos. Now let us go to the example of find first. So you might be seeing here a lot many a bigger program than the other examples, but we'll go through it line by line and we'll see what is the logic that was implemented here. Okay. So basically here the first thing in the line 13, I was trying to create a list of integers. Okay, and then I am asking the compiler to get the first element of the stream, whatever I created using list.stream method and find first. Okay, this is an optional one. So here I am trying to print the value. If there is a value available in this particular object, that particular value will be printing here in the console as part of this. If there is no value, then we will be getting the output as no value. So that is the advantage of optional class here. Okay, so this will help us in preventing unnecessary null pointer exceptions. Okay, so if there is no optional, then we need to manually do the null check and then we need to provide the implementation and we need to handle it explicitly. Since the object itself is being returned as optional, we for sure will be implementing it. There is no scope that we will be forgetting to do the null checks or any other checks while we do certain operations. Okay, so for this one, since there is a stream here, I mean there is a list here and we are converting this list to a stream using dot stream method and then we are using find first method. Since there are elements inside the list, definitely elements will be there inside the stream and we will be able to get the first element inside the stream. So definitely this optional will not be null or empty and we will be ending up here and we will be getting a value. Now let us see the second example. And in the second example, I took a string of list of strings. Okay, Java programming for NCK Hub viewers. So here what I'm trying to tell is I'm asking the JVM to get the first one, first element. Same way here also, if the first element is present, it is fine. If the first element is not present, it will give no value. Okay, and in the third one, I have created an empty stream. And same way, I'm asking how I asked for the integers stream and how I asked for the string stream. Here also for empty stream, I'm asking for the find first. If the value is there, this particular output will be coming. If there is no value, we will be getting it as no value. Now let me try to execute this program. How many no values we will be getting and how many values we will be getting. So for the first one, we got the value as 3. The first element in that is 3. And the second one, the first element is Java. And the third one, since it is an empty stream, we created as an empty one. There will not be any element inside the stream. And the find first will be of empty with no value. And that's the reason we got the output as no value. Okay, this is how we can implement for find first. And the next operation we have is all match and any match. Let us go through an example for this. So this example has both all match and any match. Let us walk through the example very clearly. So here I took two streams. Two streams are of same type. 1, 2, 3, 4 numbers. Okay. So the very first one I'm trying to see if that particular any of the stream has any numbers or not. Okay. So here what I'm trying to do in line number 13, 14, I created two streams. Two streams are of same elements, but the name of the object are different. And then I created a predicate here. This predicate will confirm whether that particular string inside from the elements that are there inside the streams, the string elements, does any of the string contains a number or not. If at all any of the string has a number, it should return false or else it should return true. So now I am using the same predicate and passing it as input to all match and any match for both the streams. Okay. Now observe the output that we get in line number 22 and 23. In line number 18, I have implemented all match method on stream using the by passing predicate as input. In line number 20, I have implemented any match on the same stream with input as a predicate. Now let us first execute these two. I mean execute the program and try to observe the output that we get for these two. Let me execute this. Run as Java application. Don't bother about the down two values. And the very first two values here we have all match true and any match also true. Okay. So it indicates that this particular predicate is not there in any of the streams. And let us take the second example where we'll have list of programmers. And here also I have a predicate. Two predicates I have declared contains Java and contains Ruby. So there are people who have Java skill set and there are people who do not have Java skill set. Similar way, there are people who have a Ruby skill set and there are people who doesn't have Ruby skill set. This is a perfect example to identify the difference between all match and any match. Okay, so here also I have taken same set of list and I created two streams on the same list and then I implemented all match and any match on by taking inputs as the same one. So here if you observe line number 34, I combined the predicates that we have declared on line number 31 and 32 and I got a new predicate here. So the predicate which is there on line number 34 is the combination of the predicates that we have in line number 31 and line number 32. Okay, so this is the final predicate which I am going to apply on the streams using the two methods all match and any match by passing the final predicate as a input. Okay, all match, any match. Now you will see the final difference. Let me execute this program and then we'll discuss on that. So if you see all match, it is false. If you see any match, it is true. So any match will be true if at least only one is true. That means like here we have two predicate conditions, right? If one of the conditions satisfies also, it will be true. But whereas for all match, it should be satisfying all the elements inside the stream. When I say elements, here we have objects, right? So it should, the predicate condition, whatever we have provided, it should match all the objects inside the stream. If all the objects inside the stream are satisfying the predicate condition that we were passing, then only all match will be true, or else it will be false. Any match, if one particular one also satisfied, that will be true. Because if you see here, there is no combination of skill set with the programmer having both Java and Ruby. So the programmer either have a Java knowledge and Ruby knowledge, but that doesn't have in all three. Only programmer do have both Ruby and Java. That's the reason we got one true there. Since we have one programmer with both Ruby and Java knowledge, so we got for any match as true. And for all match, since Java and Ruby were not there for everything, it was false for all match. All match will be true only in case where all the objects inside the stream or all the elements inside the stream satisfies that condition. In our case, only one element or one object inside the stream has satisfied the condition that we have passed in as input. For that reason, we have only any match as true but all match as false. So these are the major operations that we have as part of this video, and these are the operations which we majorly use as part of our day-to-day development. That's all for this video. Thank you for watching.